All right. Eventually, if you work hard enough, you will solve your problems. So, Nathan Beste is an information technology professional, and he travels the world. When he was studying computer science at Brigham Young University, professors would tell him that his likely career would be sitting in a cubicle writing computer code, and he does do that sometimes. But what they didn't tell him was that he'd be supporting IT systems for a global company, and there are many opportunities to work with and meet people from all around the world. So, our best for last, Nathan Beste.
I just took up 5 minutes of my time. Can you hear me in the back? Okay.
Jason, let me get from your mic. It sounds a little better.
Is it a little light? That sounds better?
Yeah.
All right. So thanks for that introduction. I'm glad to be here. This is actually my first time coming to a tech talk. You guys have been through several already today. Hopefully they've been good. Very interesting for you. I do work in IT, and I do love to travel the world. Who likes to travel here? Who wants to see the world? My daughter said, Dad, I want to see the world. I said, that's a great idea. Go into IT. I said, she decided she wanted to go in the Navy. I don't know, we'll see how that goes. But let me tell you a little bit about my company. The company I work for is called Thermo Scientific. And our mission is to help make the world safer, cleaner, healthier, cleaner, and safer. And some of the things we manufacture to allow other companies to help fulfill that mission are pretty cool. We make a lot of cool technology for genetics. Here in Hillsboro, I work for the portion of our company that makes tools that are Electron Microscopes. Who's heard of Electron Microscope? FEI is the company that is in Hillsboro that is part of Thermo Fisher Scientific. And we make Electron Microscopes there. And it's great to know that the things that I help to support, to make, to build, are used to make the world, and you, all of us, healthier, cleaner, and safer. Sometimes having a job, being in tech or not in tech, sometimes having a job, just like being at school, can be really fun. Sometimes it can be a little bit boring. Sometimes what makes it very great to be in that job, whether it's fun or boring, is knowing that you're making a difference. And I just want to impress upon all of you that whatever you do, you can make a difference in the world. Even if it's a small piece of it, you can make a difference somewhere. Whether you're young or old, it's always something you can do. Now let me go forward on this. A little bit about FEI. We make tools that are used by materials science. So think about, for example, airplanes, wanting to make them lighter, faster, more fuel efficient. They use electron microscopes to help make lighter materials that are strong. Semiconductors, Intel, right around down the road, any road you take, there's Intel all over the place, right? Semiconductors use electron microscopes all the time to help with their analysis, to help with their design, to help with their research, and in their labs. Life sciences, you think biotech, you think of the OHSU, Health Science University, Cancer Research Center. Life science is huge. They're helping to solve world cancer, and people around the world are helping to solve all kinds of diseases and find solutions. They're using tools from Thermo Fisher Scientific to do that. And it makes me really glad to know that the things that I support are being used to do really cool stuff like that. Industrial, manufacturing, lots of different areas where electron microscopes are used, as well as minerals and mining. So I want to tell you a little bit about electron microscopes, a little bit about the technology behind them, and how they're used. Now, you've all used light microscopes, I imagine, where you look through the lens and you have a flashlight or a light bulb underneath, or a reflection of the sun, to see through a plate. With electron microscopes, they have a very similar structure, but they use electrons to get the resolution instead of using light. It's an interesting phenomenon that when you speed up an electron in a vacuum, it behaves very similar to the way light behaves, in that it goes in a straight line, and the electron behaves, has the properties of light in that it'll diffract and reflect, and you can take those measurements and you can build an image off of it, just like you do with the light microscope. but at a much greater resolution. So speaking of resolution, it's the ability to distinguish between two separate objects. Right? I can see each individual student here in the room, but if you're sitting on the other side of Cornell in a classroom with no walls between us, I'd see a big mass of students, but I'd have a hard time of identifying each individual student, picking them out from that crowd. So the closer you get to something, the better you're able to resolve that thing. With an electron microscope, we're resolving things at the atomic level. We're seeing atoms on a surface of a sample that we have there. So here, for example, you can take a blow-up image of a fly. You can see the eyes, you can see the dots on the eyes of the fly, the hairs on the fly. Flies are kind of gross, so we'll move on. The wavelength. So if you think about light, light has a specific wavelength, right? It has a frequency and a wavelength. Electrons, again, as they behave like light, they have a much higher frequency, a much shorter wavelength. And that allows you to resolve things at a much smaller scale, which is why electron microscopes can see things at a much greater resolution than a light microscope can. The electron gun. So we have guns at my company. They're called electron guns. They're used to basically shoot a stream of electrons at the sample. So these microscopes, you'll see a couple of pictures I have. Tall microscopes, they're like 10 feet tall, some of them. And the column, the electron column, is where the gun shoots from the top down through these various lenses a stream of electrons to the sample. And the electron gun, it's like a light bulb. If you think about a light bulb here, there's a filament inside the light bulb. We give it power. The filament lights up. It's shooting photons out, photons of light, so we can see. Or with an electron gun, you give it a lot of power, up to 300 kilovolts of power. Think about our electric socket, it's 110 volts. 300,000 volts is a lot more, obviously. And it gives it a very high energy level for that electron source, which shoots the electron beam down through at a high speed and allows us to create those pictures. As the electron beam is going down through the column, there's coils, and those are the lenses that are used. If you think about a light microscope or glasses, if anyone wears glasses, as light goes through a lens, it bends. It bends to a certain angle that you're able to get that resolution in a light microscope. In an electron microscope, we bend or guide the electrons through the electron column using electric coils, and the more or less charge on the electric coil helps to bend the electron column. Beam, I suppose. Here's an example of a Titan microscope. A lady sitting at this microscope doing her work. We have computer monitors. But you can see how tall that microscope is. That's because that column is very tall, and this microscope gives us some of the best resolution that we're able to produce worldwide. The vacuum is one of the important key pieces that allows it to work. Again, with that vacuum, it allows the electron to work or to have the properties of light. Goes in a straight line, you can manipulate it with the lenses that I talked about, and it allows you to produce the images. Quick picture of the microscope. Inside of it, there's an electron source at the top, a series of coils and condensers. In this case, the specimen is the sample going right in the middle of it. And then another set of lenses that eventually there's a projection that comes out on the bottom. We take a picture of that with a camera, a very high resolution camera, and that's able to create these images that I'm going to show you on the computer screen. We can do 3D images by taking a lot of them. Think about being able to take a picture here, 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 all around the sample. Use some computer algorithms, put those pictures together. Now you have a 3D sample you can manipulate and work around. And scientists use things like this to identify and to study viruses, to know how to solve a lot of the, or eradicate, hopefully, some of the diseases that we have, and things like that. We can take pictures of, so here's some pictures of pollen and a few other different plant structures. Here's a nice looking dust mite, a little bit bigger than I'd like to see, but these dust mites are all over, right? They float in the air, they're so small, but with the microscope we can see them. Here's an image, a 3D image with a cutaway of a SARS virus. Who has aphids in their gardens? Might not, they like to eat the plants, I don't like them, but the ladybugs like to eat the aphids. Here's why they're so tasty, right? They look great. Who's got allergies? I hate allergies. Yeah, here's the pollen. This is the pollen that floats around in the air. Allergy season comes around, it gets up in your nose and your congestion, and what a mess. If it was this big, like really, I mean, it wouldn't be a problem, right? But because it's so small, it can get into all those passages and affects your breathing really bad, my wife especially. Everyone's got fingerprints. There's an interesting picture that I found that shows a close-up of a fingerprint. There's actually structure to it. It looks like canyons or a maze. Here's some zinc oxide crystals, a flea. No pet is a real pet without a flea, right? Hopefully you get rid of them all. Eyelashes, you know there are bugs all over your body. I hate to tell you, but I learned it on OMSI, so I'm sure you guys all know about that already. But there's a picture of some mites, little tiny bugs that are on our eyelashes. All right, let's talk about me a little bit. So that's my company. I gotta check my time because I have till 25 after. And so that's my company. That's Electron Microscopes. I hope that learning about those a little bit maybe gave you some interest. One of the things that I've found in life is that there's a lot of opportunities to learn about lots of different things. In school, you have a great opportunity to go to all their different classes, take different electives, learn about things that interest you specifically. And the great thing is, there can be a lot of things that interest you. I found in my life, how did I get into IT? Well, I started out in 6th grade programming on these little computers, saving things to cassette tape and having to rewind and fast forward to just the right number to start my program loading, or to save my program to the tape and not overwrite my previous program. I went to high school, I took a couple classes, it was really interesting. I went to a summer camp about learning programming in, I think it was Pascal at the time. I learned BASIC in high school. I don't know, anybody take computer programming classes these days? What are you learning? Java? C? What do you learn? What programming language do you use? Anybody?
We teach about 8 here at the school, so.
I'm sorry?
I said we have probably about 8 different languages that we're teaching.
Okay, so lots of programming languages maybe if you take computer classes. There's lots of them out there. My point is, that's exactly right. There's lots of things out there to study. There's lots of things to learn about. And in my experience, the more I learned, the more I found I was interested in something. The more I got familiar with something, I found out it was something that I was really excited about. So in high school, I took these classes, and then this was back in the late 80s, when there really wasn't a big field for computers. We barely had a small little PC that connected to my TV, or the small little TRS-80 you'd buy at Radio Shack type of thing. You guys probably never heard of those, that's okay. But computers weren't really big at the time, but they were interesting to me. So when I went to college, I thought, well, computers, that's interesting to me, but it's not really a career, so maybe engineering. So I tried engineering, I didn't really like it. Maybe science, I liked physics, so I looked at physics, I didn't really like it. And then I looked, and there was a computer science class. I thought, I love computers, it sounds great. So eventually I went and studied computer science. That was my degree that I got in college. And I loved it, and I enjoyed it. And then I went into a job where, like I was mentioned in my introduction, you know, college school professors said, oh, computer science, you guys are going to be programming. You guys are going to be sitting in a cubicle writing code for whoever your employer is. You guys are going to be looking at a lot of computer screen monitors, which I do, granted, but everyone does that these days, right? Everyone looks at monitors now. What I didn't realize was that if I get into computers, and if I go to a company that has international manufacturing, which I didn't know what manufacturing was until I really started working for a manufacturing company, that they're going to send me to places like Brazil and the Netherlands and Germany and the Czech Republic and Italy and Australia to help support their computer systems. So from here on the stage, I'm going to encourage all of you, go study computer science if you want to travel the world. Because in a computer age, and the age of global manufacturing and global companies, there's a lot of opportunity to go and see the world, meet people from different parts of the world, to interact with people from different cultures, to experience how people work in a different way, but a similar way, so that you can build on those relationships. And for me, computer science was my ticket to allow me to have these experiences. I hope that for you, you find ways that you can make a difference in your life, in the lives of those around you, and maybe in the world. I hope that you end up doing what you love. I hope you find what you love, maybe many things that you love, and you do it, because that makes life and your career all that much more enjoyable. Be flexible, accept challenges, look for opportunities to learn new things. Always try to learn something new to keep your skills up to date, to keep yourself motivated, and to keep yourself always thinking about what's the next great thing that you can accomplish in life. With that, my presentation's over, and I'll open it to any questions you might have. No questions? Oh, come on, tell me, go ahead.
What is your favorite programming language?
My favorite programming language? Well, I'll have to say that my current job, I've been doing this for probably 15 years. I work in a programming language called Progress. It's a programming database as well as a programming language. And it's my favorite only because I use it all the time, and I'm much more familiar with it. But I do like Java. I've used C. It's been a long time, so I can't say that's my favorite. But good question. Thank you. What's yours?
My question?
What's your favorite?
My favorite, I would think, is Java.
Java. Very flexible. Very flexible. Actually, Java just came out at my last year of college. It was invented my last year of college back in 1995, 96. So I didn't have an opportunity to learn it before, but I have picked it up since. Thank you. Any other questions? In the back.
What class did you like the most in college or high school?
Oh, my favorite class in college, I'll go to my computer science class. In high school, I liked tinkering with the programs that made things change on screen. I wanted to be able to see my results. So I liked the graphics programming type things. I would, make a line, okay, that's a good start. Make a box, now make more points to make a circle, and then change the diameter to make spirals, and all kinds of different things you can do with programming in the graphics. And so in high school, I took a graphics programming class. That was pretty much one of my favorites, I think. Again, because I like the visual element of it, the artistic element of it. I don't do that today. Today, my programming today is all about business programming. So in business programming, I'm supporting and programming things that help people to manage their inventory, help people keep track of their sales orders, help people know what things they need to buy so that they can build the right tools to meet the sales demands, to sell to customers, to ship it out, and to make sure they get the invoice, the money back. Those are the kinds of things that business programming is. It's interesting. It's not as fun as graphics, but it's very interesting. So, thanks for the question. Any other questions? Another one. Go ahead.
If you were to recommend a programming language to someone who's considering trying out programming, what language would you first recommend?
For trying out, I would say Java, because it's a fairly simple one to learn, I think, and it's pretty popular. It's used a lot in lots of different places. There's a lot of different sample code to look at. And one of the great things, if you want to learn about programming, look at sample code and then manipulate the code to see how it changes things. That's a great way to learn. So Java's good. Also C and C++, because really if you go into a more programming-centric job, those are very common languages. Good question. What else?
What was the most interesting place you had traveled to?
Ah, that's a great question. So I really liked Italy, I have to say. They took us to this place. The factory was at a town on the coast of Italy. They put me up in this hotel that was right on the beach. The Italian food was amazing. The Italian people were very kind, very friendly. I took a weekend trip once. I took the train down to Rome. I got to go visit Rome and tour on the bus there and walk around. It's an amazing city. If you ever get a chance, I really encourage it. But I'd say Italy is one of my favorite places to go. But I've got a lot of different favorites in different ways. Thanks. Any other questions? Are we on time?
Okay, thank you very much.
Thank you all.